Hello and welcome to the topic of the Earth. In this lesson, we're going to discuss what are Earth systems. Now, the big idea of the topic of the Earth is basically, how can you describe Earth? It's a very big place, so we want you to learn how to describe it. In this lesson specifically, we're going to look at four things. What are Earth systems? What are the composition and structure of the atmosphere of Earth? How is water distributed in the hydrosphere of Earth? And what are the composition and the structure of the geosphere of Earth? So let's begin with some key vocabulary. Now, the first is biosphere. Biosphere is the Earth's system that contains all living things. So obviously the biosphere is very big. I mean, all the plants, all the animals, all the humans, it's all part of the biosphere. You then have atmosphere. Atmosphere is the thin layer of gases that surround Earth, or what we would call the sky. But it's more than just the sky. So everything from the Earth's surface all the way up to space is called the atmosphere. And it's made of different layers of gases. You also have the hydrosphere. The hydrosphere is the system containing all of Earth's water. All the rivers, groundwater, ponds, etc. It's all hydrosphere. Groundwater is water that is stored in cracks and pores beneath the Earth's surface. We call that groundwater. The geosphere is the solid part of the Earth. Right? It's not the atmosphere, it's not the hydrosphere, it's the solid land. And in the geosphere, you have something called minerals. Minerals is a solid that is naturally occurring. It's inorganic, meaning it's not alive, and usually has a crystal structure and a definite chemical composition. You also have a rock. A rock is a naturally occurring solid, and this can have many different things combined into it, maybe compressed or melted into each other. So it can have rock, minerals, rock fragments, other materials, etc., all made into one specific lump. So let's go ahead and begin your lesson. So we already said that the scientists divide Earth into systems to better understand our planet. And the biosphere is where all life is, right? And then you have atmosphere and hydrosphere, and you even have the geosphere, right? And the geosphere, they can combine it down even finer into different layers, just like the atmosphere can be defined into different layers. Now, the outermost system is the invisible layer of gases surrounding the planet, all right? And below those gases is the system that contains Earth's water. And then you also have the solid part of the Earth. And that is the soil and the rocky center, etc. So again, you have the atmosphere, the hydrosphere, and the geosphere. The gas, the liquid, the solid. Now, within all these, you have the system containing all the living things. And the living things can be in the atmosphere, or in the geosphere, or in the hydrosphere. And we call these, all the living things, the biosphere. So the biosphere can have all the other spheres into it. Now, Earth's gravity pulls gases into layers that surround the Earth. And all of these layers make up the atmosphere. The atmosphere is basically a mixture of different things. It has nitrogen, oxygen, and, a small amount of other things. For example, pollution, carbon dioxide. So all of this makes up the atmosphere, but the main part of the atmosphere is nitrogen. We need the part that's made up of oxygen. So let's do another key concept check. What is the composition of the atmosphere? Well, as we said, it's a mixture of nitrogen, oxygen, and smaller amounts of other gases like carbon dioxide or CO2. Now, thermal energy from the sun will heat our atmosphere, but different parts of the atmosphere absorb or reflect that heat in different ways. To absorb means you take it in, and to reflect means it bounces off. All right? So the heat comes in, boom, it bounces off and goes back out. Or the heat comes in and it's absorbed and spread out. Now in the bottom layer of the atmosphere, which is called the troposphere, that's where we are. All right? And there it's warmer because the Earth is giving off heat or absorbing the heat and heating up. But there are also different temperatures. And the gases, they flow and swirl, and this causes our weather. Because you have all these different gases in the troposphere, which is where we are, right? And they're different temperatures. And so they're swirling around, and weather is caused by this movement and when they connect with each other. When all these different temperatures hit, it starts causing our weather. Now the stratosphere right above that is a little bit more stable, and it's not as warm, but it's still warm, and it has the ozone layer. But that's where you have a much more stable and flat area where you don't have all this swirling and different temperatures and the weather that we have in the troposphere. The mesosphere, which is right above the stratosphere, all right, that is where the temperature starts to go down. So as you go up in the mesosphere, the temperature decreases. All right? It starts to get colder. Now, surprisingly, when you go into the next layer, which is called the thermosphere, right? Because we just left the mesosphere. And the mesosphere is where the temperature started to go down, right? So now we're in the thermosphere. That's right above the mesosphere. And there, it's funny, but the temperature goes up again. As you move further from the Earth's surface through the next layer, through this thermosphere, the temperature starts to go up because it's absorbing more of the sun's energy or heat. Whereas the mesosphere does not absorb that much. It reflects it or lets it pass right through. And then the outer is called the exosphere. The exosphere is right before you enter space. So it's our very top layer, and it's very huge. And it's also where you'll find our satellites, etc. So what are the layers of the atmosphere? Well, they are the troposphere, the stratosphere, the mesosphere, and the exosphere. Those are the different layers. Again, troposphere, stratosphere, mesosphere, and exosphere. Now let's look at the hydrosphere. That's where all the water is, right? We call that the hydrosphere. The water in the hydrosphere changes state between liquid, solid, and gas on Earth, right? So 97.2% of the water in the hydrosphere on Earth is in the ocean, right? Only 2.8% is not in the ocean. And of that 2.8%, about 2% is frozen as glaciers, right? Another 2% is under the ground. And another 0.25% of that original 2.8% is located on the Earth's surface or in the atmosphere. So you have lakes and soil water and atmosphere, etc. So that's a lot of the fresh water, along with underground water in glaciers. So it continues to go down and down, but the vast majority of water on the Earth is salt water in the oceans. So again, 97% of all water is in that ocean. And you can get even more detail about the fresh water. All right, fresh water means no salt. And again, 68.7% is frozen. 30% of the fresh water is groundwater. And remember, fresh water is only 3%. 3% of all of Earth's water is fresh water. Then you start looking at what is on the surface, what is in rivers, what is in swamps. I mean, they continue to cut it down. But the big thing to know is that 97%, right, is in the ocean, and 3% is fresh water. Now, groundwater, what we talked about, that's water that's underneath the surface. And this is very important, for example, when you build a little house. You know, someone builds their house, and then they build a little well, and they drill down to the groundwater, right? They drill down below something called the water table, because then they want to basically build that well with a little bucket that they can bring it down and get their groundwater underneath the water table. So, another key concept, how is water distributed in the hydrosphere? How is it circulated or provided for in the hydrosphere? Well, it is moved around or distributed in oceans, rivers, lakes, swamps, groundwater, etc. So you obviously have the ocean, and then it's distributed in many different other areas. So the ocean is the big one. Then maybe some rivers, and then a lake, maybe a swamp that has a lot of groundwater, or a surface water, and then groundwater that's underneath the Earth's surface. Now let's move on to the geosphere. The geosphere is the solid part of the Earth, and it usually includes that thin layer of soil and broken rock material. This is where we live, but it also is all the underlying areas of rock. But usually as humans, we see and we're concerned with the soil, where we grow our stuff. Now, in the geosphere, you have minerals. Minerals are valuable. They are naturally occurring inorganic, which means they are not alive. And they usually have a crystal structure, and they have definite chemical makeup. You know, each one is very unique. So it has a very specific type of chemical makeup. All right? And we use these minerals for many different purposes. Now, a rock is naturally occurring, but it's not like the mineral, it's not one specific chemical makeup. It has lots of different things inside of it. It's not one specific thing. It can have other rocks, it can have different types of minerals, it can even have organic matter, you know, like plants, etc. Now, there are three major groups of rock types. They are igneous, sedimentary, and metamorphic. Let me repeat that. Igneous, sedimentary, and metamorphic. Now, another key concept check. What are Earth's systems? We just talked about them. So what are they? Well, they are the atmosphere, which is the air, the biosphere, which are plants and animals or anything alive, the geosphere, which is the land, and the hydrosphere, which is the water. So you have the atmosphere, which is the air, the biosphere, which is all living things, the geosphere, which is the land itself, and the hydrosphere, which is the water. Now, when we talk about those igneous rocks, Remember we talked about the three main types of rock? Igneous rocks are formed when molten material, and we call that magma, when it starts to cool down, it gets hard. All right? Now, magma is what comes out of a volcano. That's magma. Right? So magma comes out, and when it hits the Earth's surface, magma is called lava. Right? When it's under the Earth, we call it magma. When it shoots out, it's called lava. So all that lava on the Earth's surface, or magma, if it cools, when it cools and hardens, that forms an igneous rock. Sedimentary rocks, right, form when forces such as water, wind, or ice kind of break apart the rocks. The rocks start to fall apart. And we call that sediment. That's why we say sedimentary rocks. So you have a sedimentary rock, right? And it can break apart into sediments. And that's how it forms. Now, that's usually what happens is a metamorphic rock breaks apart to form sediments. And then the sediments form sedimentary rocks. Metamorphic rocks are formed from extreme temperatures or pressures, pushing on those rocks, squeezing them together, and that makes new rocks. All right? So, again, igneous rocks form from when something cools and it hardens. Sedimentary rocks formed from different little particles, right? And they all kind of clump together. They're not pushed together. They're not squeezed into a new type of rock. They're just kind of put together in little particles, and it's called cementation. And that's how we get the sedimentary rock. So it's from sediments that come together and to form a rock. And a metamorphic rock is from a lot of melting or heat and pressure, taking that rock and fusing it together into a new rock. So sedimentary, again, is, kind of pushing them together, but you notice there's still grains, or they're still separate. But metamorphic is when that pressure and that heat gets so great that they start to fuse together in a new rock. Now, there are three basic layers of the geosphere. They are the crust, the mantle, and the core. Now, the core can be separated into two, inner and outer. But the three big ones are crust, mantle, and core. Now, the crust is the outer layer, very thin outer layer, and it's made up of the soil and some rocks, etc. And we call that the crust. It's what we can see. It's the Earth's surface. The largest part of it is called the mantle. And the mantle is made up of all these rocks, and the rocks are being squeezed together to form metamorphic. They're turning into igneous rocks because they're melting and then hardening again. So all of that is happening underneath the Earth's surface in the mantle. And then in the center of the Earth, we call it the core. Now, this is mostly iron and nickel in liquid form and solid form. All right? So you have a solid iron core. And then you have, the melted one that's in the center going around, spinning around the solid part of it. So what are the composition and the structure of the geosphere? Well, there are three basic layers of the geosphere. The crust, made of rock, the mantle, made of hot, dense rock, and the core, made of iron and small amounts of nickel. So again, crust, mantle, core. So in summary, remember that the Earth is made up of four interacting systems: the atmosphere, the hydrosphere, the geosphere, and the biosphere. The atmosphere is mainly gas. The geosphere is mainly rock, soil, and metal. And most water in the hydrosphere is in the ocean, with some, about 3%, being fresh water and 97% being the ocean. Thank you, and I hope you enjoyed the lesson on what are the Earth's systems, and looking forward to seeing you in the next lesson. Thank you.